All right, kiddos, so today we're going to try to talk about waves in a little bit of a different direction than we did last time. So we're going a little bit deeper, and instead of just talking about waves as far as frequency and things like that, we're actually going to be talking about light and how light relates and plays into some of those waves. So one way that we can kind of think about light rays that we can't see is when we look at something like X-rays. So X-rays, they're a medical tool. Some of you may have had them, some of you may not have, some of you may know people that have had them. But basically what happens is the beam of the ray gets like fired at the person in whatever area that they're x-raying. And some of the x-rays get absorbed by the tissues like bones and teeth. But other rays pass right through. And so the more that they pass through, the darker the image gets. So that's why bones look white when you do an x-ray, because they absorb it versus letting it pass through. But x-rays, because they are literal beams of light energy waves getting sent at you, doing too many x-rays can actually be very harmful for a person. And so that's a lot of what we have to consider when we're looking at using some of these different types of waves. So there's things like x-rays and things like visible light, and both are types of electromagnetic radiation, and all of that travels in waves. So when we think about light waves, we're thinking about like visible light, infrared rays are light waves, ultraviolet rays are light rays, but other types of electromagnetic rays would be like radio waves, gamma rays, x-rays, microwaves are also another type of electromagnetic wave that's different than our light wave. But they're all related as far as what they're used for. We're going to kind of dive deeper into the meaning of infrared and ultraviolet, but some things to know. Some organisms can sense infrared light. White light is actually composed of all colors of light, so you only get white light by having all of the colors of light. The color of an object actually depends on the colors of light that it's reflecting. And visible light and invisible light all travel at the exact same speed. So those are just some kind of facts to know, some fun facts to know. Just a review from last time, when we're talking about waves, we have our three properties that we did previously. So we have amplitude, wavelength, and frequency. So remember that amplitude is when you're measuring from that main middle piece of the wave to see the distance between the middle and either the lowest point or the highest point. So either section would be measuring amplitude. Wavelength is the distance between two low points or two high points on a wave. So it's the distance between the waves, or between the amplitudes. And then frequency is when you say, okay, we're going to measure it for this much time, and we're going to see how many times we hit a certain point during that piece of time. And that's how you get the frequency. So those are all properties of electromagnetic waves and waves in general. So when we talk about electromagnetic waves and visible light, we end up looking at what's called the electromagnetic spectrum. And it's literally this kind of chart that scientists designed that show us all the different electromagnetic waves on one chart. And it goes from like your biggest spread out of that wavelength to the tightest wavelength. So on all of that, we have radio waves, microwaves, infrared waves, ultraviolet rays, gamma rays. It's all a type of radiation that occurs naturally, and so it's all put on this electromagnetic spectrum. So again, it's all arranged by wavelengths. So you go from the long wavelengths to the shortest wavelengths. They each change gradually. So like each section is a little bit longer or shorter depending on which way you're looking at it. So just one property that they use to do that is wavelength, but we know that waves have many other properties. So another property would be frequency. And so like as you're going from the one side of the electromagnetic spectrum to the other, you can also observe changes in frequency. So like wavelength and frequency are inversely related. So if a wave has a long length, then its frequency is really low. But if a wave has a short length, then its frequency is really high. So that's how when you're looking at the electromagnetic scale, you can also look at it via frequency instead of wavelength if you understand that that's how those things are related. Energy is a third property of waves that kind of varies along the electromagnetic spectrum. So energy is directly proportional to frequency. So if the frequency increases, so does the energy. If the frequency decreases, so does the energy. So they go hand in hand together. They're like besties. Okay. So visible light is light that we can see. And the section on the electromagnetic scale that represents visible light and light that we can see is very small. It actually really surprised scientists when they first started working on this, because I think it's like natural as humans to kind of think that like what we see and what we know must represent everything, right? Like we're geniuses like that, it must. And then instead, as they were discovering and exploring this, they realized that what we knew was so small compared to all of the waves that we are unable to see. The visible region of the spectrum only includes things with wavelengths from 400 to 700 nanometers, which is crazy small. Like 700 nanometers would be like a length of a bacterial cell, and 400 nanometers would be like a particle from a virus. So we're talking very small lengths here. Just below the visible region that we see on the other side of that 400, we get the infrared region. So infra, that root, it means below. And so when you're looking at your spectrum and you see that visible light, that infrared is going to be below that. So it has a lower frequency, longer wavelengths than visible light does. So a lot of materials, including like human skin, can absorb infrared waves. And the energy of the waves is often transferred as heat. And so that's why sometimes infrared waves are considered heat waves. So on the opposite side of that, so we had our infrared, our visible light, our infrared on one side. Now we're looking at the opposite side of that. So on the opposite side, we have ultraviolet rays. So ultra means above. That prefix means above, just like the prefix infra means below. So they literally are opposite of each other. So meaning above means it's going to have a higher energy, shorter wavelengths than your visible light. So, like, the sun actually emits a lot of ultraviolet rays, and those ultraviolet rays are what can give us, like, sunburns. Like, that's why we wear sunscreen, is to protect from ultraviolet rays. We have the ozone layer that is also blocking a lot of those, but some do get through, and as the ozone layer gets damaged, more things get through, and so having that sunscreen on is really our only tool to protect from that ultraviolet radiation that we get from the sun. Okay, so we've talked about visible, we've talked about infrared, we've talked about ultraviolet. There's still some other things that happen on this chart. So the electromagnetic waves that are on the farthest side of your chart that have the lowest frequency and the lowest energy of all the radiation types are called radio waves. And then when you're looking at the opposite end of that, the waves with short wavelengths are going to be your X-rays. They have short wavelengths and greater energy than your ultraviolet rays. You're also going to have gamma rays on the opposite side of that. They have the absolute shortest wavelengths and the highest frequencies. So we have gamma rays on one end and we have radio waves on the other end. So it's radio, infrared, visible, ultraviolet, X-rays, gamma rays. And so the energy of the wave increases with the frequency, which is why your X-rays and your gamma rays have the strongest penetrating power and can be the most dangerous. So things to remember, the length of an X-ray wave is much shorter than the length of like a particle from a virus. Scientists originally thought that we knew a lot about visible light and that was the majority of things, but 500 years later, we've discovered much more than that, and that's where this electromagnetic scale has come from. And so those are things to keep in mind, just kind of key points to go over. So another way that we use these waves is with communication. So when you think back to our great lessons, even when we talked about just way back before they were even writing symbols or anything like that, the only type of communication was verbal. And so if people were far away from each other, they really didn't have a good way to convey those messages at the time. But later, when we get to the creation of writing, we start seeing that people come up with different ways to communicate. But as time has gone on, we've found even more ways to do that with technology. So we do things like the internet and email and text messaging and Facebook. There are also things like cell phones and radios and television. Those are all forms of communication that go long distance. And all of those things have used research from electromagnetic radiation to create these things that we use regularly now. So the discovery of radio waves happened in the late 1800s, and that really kind of opened up that ability to start communicating long distance. And then as we've learned more about microwave radiation, that's also helped become a medium, a way to communicate. So it involves a lot of equipment to transfer these waves. So they need transmitters, and then the signal is sent through the transmission line to an antenna, and then the antenna sends the radio wave or microwave signal into the air, and another antenna, a second antenna, receives that signal and transmits it to the receiver. So as you're looking through your science unit, you'll actually see a diagram of that, and I think that'll be helpful for kind of seeing that when you're thinking about communication that way. So radio waves, microwaves, infrared waves, and visible light are all used in wireless communication technologies. So basically the information gets kind of encoded in wave pulses of very specific frequencies, ensuring like rapid and reliable transmissions. They travel extremely fast. And as they travel, they maintain a constant frequency that doesn't change, and it can't be changed by objects or weather conditions or temperature or humidity. It doesn't get impacted by any of that. Now, it can't pass through substances, but it can be reflected or refracted off of these things. And so we actually use that knowledge of reflecting and refracting to kind of direct waves to certain things so that these transmissions get to where they need to go. So even though they're not corrupted by the environment, even though a giant storm is not going to have an impact on the specific wavelength, wavelengths can interfere with each other. They can overlap, and when that happens, we do get interference, and that's when we tend to have issues with being able to hear or with being able to clearly understand the message that is coming. So yeah, just a main point from that, electromagnetic wave and electromagnetic wave maintains consistent and constant frequency, and it's unchanged by environmental factors. All right, guys, we are at our main points, so just kind of a review. Infrared waves are next to visible light on the electromagnetic spectrum. Infra is a prefix that means below, so it's under the visible lights. They are often transferred as heat. We sense them as heat. And so those heat waves can come off of living bodies and can come from lamps, things like that. Like the heat lamp that we use for sunset, that is using infrared light to heat sunsets home. Ultraviolet waves are on the flip side of our visible light, so those have higher frequencies, shorter wavelengths. Stars can radiate UV rays, the sun can radiate UV rays, and the sun UV rays are what give us sunburns, and that's why we want to wear sunscreen. Other types of waves are radio waves, microwaves, X-rays, gamma rays. Radio waves are the lowest frequency, and gamma rays have the highest frequency. I hope that this helps.